Okay, so we are starting chapter 5, solving systems by graphing, and we are going to be talking about systems of linear equations. So we just finished our chapter on linear equations, so you should all know that a linear equation is written in the form y equals mx plus b, and now we are going to be using those to do a lot of graphing with more than one equation on a graph and deciding how the solution set looks as a system. So two or more linear equations in the same variable are called a system of an equation. And a solution of a system of linear equations in two variables is an ordered pair. So we're always going to see two linear equations called a system, and their solution set is an ordered pair. So we're going to start by dealing with, is this a solution of the ordered pair? So when we take a look at letter A, it's telling us that the solution is 5, 2. So we are going to actually just substitute in 5, 2 and see if it works in the solution set. So for the very first one, we're going to put in 5 for x and 2 for y and see if it comes out equal. So we get 15 minus 4 is 11, 11 is 11. So that first one works. So in order for something to be a solution, it has to work in both equations of the system. So we have to try both of them out. So in this next one, we put in 5 for x and 2 for y. And we solve the solution to be 7 equals 7. So yes, 5, 2 is a solution to this system. Moving on to example B. In example B, we're going to substitute in -2 for x and 1 for y. And we get -15 equals -15. So the first solution works. Solution number 2, substitute in again, -2 for x, 1 for y. And we get -3 equals -3. So yes, -2, 1 is a solution of this system. Looking at letter C, checking to see if 3, -6 works. We get 3 minus 18 equals 15. And this comes out -15 equals 15. So because this one does not work, we do not have to check our second equation. So we can just say, nope, 3, -6 does not work. Looking at letter D, x equals 3. So you do still need to plug in the ordered pair. So we have to say 3 is equal to 3. So that is an automatic check. And then we have to check the other one. -3 times 4 equals 12. -12 does not equal 12. So this one is also a no. So when you're checking solutions, all you have to do is plug in the coordinate pair x, y for the x, y values in the systems. You have to check both systems, and they both have to work in order for it to be a solution to the linear system. All right, moving on to graphing. So we know that when we graph a linear equation, it has to be in the format y equals mx plus b, because we have to know the slope and the y-intercept in order to put an equation on a graph. So in letter A, I can immediately see I do not have this format. So the first thing that you're going to need to do is you're going to need to solve this for y equals mx plus b. When I do that, I'm going to take away 6x from both sides. And I get negative 3y equals negative 6x minus 15. I have to divide every term by the negative 3. And that gives me y equals 2x plus 5. My slope, I want to write in fractional form, 2 over 1. My y-intercept, I want to write as a coordinate pair, 0, 5. And I now can graph this. When I graph it, I go up and I put my y-intercept in first, and then I use my slope. As you can see, if I go up 2 and right 1, I'm off my graph, so I immediately know I need to go down 2 and left 1 in order to graph this system. With systems, you do need to take your graph all the way across the graph and make your line as straight as possible. So I'm going to try that one again. That's much better. And there is my first linear equation. Now I'm going to do my second system. Again, I need to solve this for y equals mx plus b. So I subtract 2x on both sides, and that leaves me with y equals negative 2x minus 3, with my slope being negative 2 over 1, and my y-intercept being 0, negative 3. When I place this on the graph, I'm going to go from the origin down to negative 3 for my y-intercept, and then I'm going to graph it down 2 and right 1, and I obviously run off the graph. So then I have to go in the opposite direction, up 2 and left 1, up 2 and left 1, and I'm going to do this all the way up my graph until I run out of space. Connect my linear equation with a line, and you can see that the first thing that you spot is that you have two coordinates that match. A solution to a linear equation are exactly that coordinate point where they match. So the solution to this system set is negative 2, x value first, positive 1. Looking at example B, the first solution set is going to come from the equation 3x plus y equals 11. I have to have this in y equals mx plus b format, so I subtract 3x from both sides. That gives me y equals negative 3x plus 11. My slope is negative 3 over 1. And my y-intercept is 0, 11. I'm going to place that on my graph. So 0, 11 is right up here at the top of the y-axis. And my slope is going to go down 3 and right 1. When I go down 3 and right 1, I'm going to carry that all the way through my graph until I get to the very bottom. I'm going to connect all of my coordinate points. Oops. Making sure I have arrows on my linear equation. And then I can move on to my second one. So I have x minus 2y equals 6. I subtract x from both sides to get negative 2y equals negative 6. Negative x plus 6. I divide each term by -2, and I get y equals 1/2 x minus 3, where my slope is 1/2 and my y-intercept is 0, -3. Down from the origin 3 spaces, I have my y-intercept, and I'm going to go up 1, right 2. I'm going to do this until I have enough points that I've made a connection to my other graph or my other solution. And I've done that. And so I can see the point at which they intersect is 4, -1. So my solution to this system is 4, -1. So in review, solutions of systems are when you graph two linear equations in the format y equals mx plus b in order to identify your slope and your y-intercept. The solution is where the two graphs intersect, and you can write a coordinate point for those. So what you're going to do is you are going to go down here to the bottom, and I would like you to do the practice solving by graphing. So you're going to do this set, which has 3 problems, A, B, and C. You are going to go and you are going to skip. I'm skipping over sections 2 and 3, and we are going to talk about those tomorrow with what we call special cases of graphing solutions. But I do want you to go down here to the bottom, and I want you to try the solving by graphing. So there's A, B, C, D, E, and F. And you're going to go and you can check those when you are done. We are going to go through example 3 together, and then I'm going to have you do example 6 on your own. So let's take a look at example 3. Bryce and his sister Julia each have a savings account for college. In April, Bryce's account had a balance of $2,000, and he had plans to deposit $50 per month. At the same time, Julia's account had a balance of $1,600, and she had plans to deposit $100 per month. Predict when Bryce and Julia will have the same amount in their college accounts. So the first thing you need to do is write a system of equations with 2 variables. That means that you need to actually figure out what are the equations for Bryce and Julia. So this is something we did back in the last chapter, linear equations. So for Bryce, I can see that if he has a balance of $2,000, I know that that's plus $2,000 no matter what else he decides to save. Then he plans on depositing a $50 per month. So we know that that's his slope because it's a rate of change. So $50 per 1 month. So we can fill in our y equals and our x, and we can move on to Julia. Julia is very similar. She has a balance of $1,600, but she plans to deposit $100 per month, which is our slope. So y equals 100x plus 1,600. So now I can take both of these systems and I can put them on my graph. So we're going to do Bryce first. We know he has a y-intercept of 0, 2,000. And he has a slope of 50 over 1. So I'm going to put in 0, 2,000. That 0 is missing. Okay, and so this looks a little different. The graph just represents in number of thousands. So when we look at 2,000, we're going to graph it on 20. And then we're going to go up 50 and 1. Because on the bottom it counts by ones. And then on the left, each one is over by $50,000. Okay, now we have Julia's to graph. We know Julia has an intercept of 0, 1,600. And then we have a slope of 100 over 1. So we go over and we graph at 1,600. And then we're going to go up 100 and over 1 for each. Remember, the left side's counting by 50s. So we're actually going up 2 bars every time. And we can see that their graphs intersect right here at the top at the point 8, 24 or 2,400. So in 8 months' time, they're each going to save $2,400. All right, so now you are going to try to do the same thing in problem number 6, and then you can check your work. So again, to kind of go back and review what you should be doing on your own and what you shouldn't be, you're doing number 1, problems A, B, and C. Then you're doing problem 5, A, B, C, D, E, and F, and then you're trying number 6 all on your own.